Okay, so the ketones themselves, remember, are a double bonded oxygen, and this is going to be different than what we had with our aldehydes. The aldehydes, double bonded O is always on the end. With ketones, they're sandwiched in between um, the middle of a hydrocarbon. Okay, and it's got a pretty easy way to remember how to write them. You just end it with one. So you just name the hydrocarbon and then just put O-N-E, not the number one, like the word O-N-E. Okay, so like if it's, in this case, that'd be prop, okay, because it's three. They're all single bonds, so it'd be propane 1, propanone would be the name of it. So it's not that hard to name ketones. Like we talked about the other day, ketones are found all over the place, especially in metabolism. Okay, you'll notice a lot of metabolic things going on with ketones. Okay, carboxylic acids. They look kind of daunting and really, really hard to figure out what's going on. But what basically happened is with a carboxylic acid, it's an aldehyde and an alcohol put together. Because here's the alcohol and here's the aldehyde. So when you combine an aldehyde and an alcohol, you get what's called a carboxylic acid. And these are really, really important in organic chemistry. They're organic acids. Okay, they're things that you're going to be dealing with a lot when we start studying the Krebs cycle. Okay, all right. The way that you name carboxylic acids, you just take the longest chain and then end it with oic acid. So in this case, this is ethane. So you just say ethanoic acid. So if it was 5, it'd be pentanoic acid. 8 would be octanoic acid. So you end it with oic acid. That's the way that you deal with carboxylic acids. Again, it's it's an aldehyde with an alcohol. Okay. And you can read this if you want later, but again, they're found all throughout the Krebs cycle. Like every single stage is a carboxylic acid of the Krebs cycle. So this is probably the most important one that we talk about, because you're going to have to memorize these after winter break. You have to be memorizing all of these here and here. Okay. All right, and then finally, again, I took out several from years past. Okay, I'm only making you memorize 7. We used to do 30. Okay, so this is probably the one that gives people the fit the most, because it doesn't fit with anything else. Okay, but I just put it in there because I think it's one of the easier ones to name. It's a single bonded O that's sandwiched in between 2 ethanes. Okay, I'm sorry, alkanes. Yeah.
So is the ketone only when the O is on top of the thing?
And double bonded. Yeah, when it's got 2 lines going to it and it's sandwiched in between 2 carbons, it's a ketone. If it's on the very end, it's an aldehyde. So with the ethers, there's a couple different ways that you name it. What I would like for you to do is just name the 2 alkanes that are in between it, and then just put ether at the end of it. So this is an ethyl, this is a methyl, and then just put ether. Sometimes you'll see it named with oxy in the middle of it. I'm not going to do that this year. Just deal with whatever the chain is on the left, whatever the chain is on the right, and then do it alphabetically, and then say ether. Okay. Ethers are they're used in fuels, gasoline. They used to be used as an anesthetic. That's how they would knock people out for surgery.
Oh, and Isn't that like a drug?
Yeah, it's like they would put it on a cloth. If you ever watch like old timey movies or whatever, and they'll put somebody to sleep before they like do an operation, they would like put ether on their mouths and then they'd breathe it in and they would go to sleep, supposedly. The problem with ether is extremely flammable. So a lot of operating rooms would catch on fire, like a lot. Things would blow up because ether is really, really flammable. And it's fairly caustic. In other words, it causes harm. It's not like a great anesthetic. Yeah, so that's it. That's all the notes I got for you. Okay, so what I want you to do now is take out a sheet of paper. If you need a sheet of paper, I got some up here. And we're going to go through what's called the general formula for these things.
When's our tennis?
We're going to have a quiz on Friday. Oh, you weren't in here, were you? Yeah, we have a quiz on Friday. So we're not having a test. We're going to have a kind of an extended quiz the following week. So, but nothing big.
When do we go on break?
You guys are done what? You guys are done Tuesday.
Like next Tuesday?
Yeah, like next Tuesday. Okay. So we've had several of these things, and this is kind of a review to go over all of them. Remember, whenever you see an R, it just stands for, like, in math class, it's a variable. So it could mean anything, okay? It's just a way of writing like X, okay, in math class. So the general formula that we have for the very first one that we studied looks something like this, okay? And that is a alkyl. All right. And the way that the ending on these things, okay, is YL. I'll tell you what, I'm just going to go ahead and give you this part. I'll just do it on this. It'll be easier for you rather than just fill this chart out. A little bit more organized for you. Okay, so what we've got over here is the group name. So the first one's already done for you. Alcohols, the way that their general formula is made, it looks like this. Okay, and that little OH part, it's called a hydroxyl group. Not that you have to know that, but if you ever see it again, like chemistry or whatever, it's hydrogen and oxygen, so it's hydroxyl. That's why it's called hydroxyl. The way that you the naming of this, the ends in a suffix OL. Okay, and then like a specific name. Let's go with ethanol. And then the structure example would be like that. And again, please don't get confused by the line, because there's two carbons here for the ethane part. 1, 2. This line doesn't have a carbon on it because it's got an OH at the end. All right, so there's not 3 carbons here. There's only 1, 2 carbons here. Okay, so then we have this thing, the aldehydes, and what it's going to be, it's usually you put like the R, and then they they'll put like they'll do it a couple different ways, but usually it's like this. And it ends with AL. So like propanol. All right, so then your haloalkanes. Um, this can be a little confusing because you'll see it like this, and the X can equal I, it can equal Br, it can equal F, and it can equal Cl. And these don't really have a different ending to them. It's the way that usually the naming of it is like, and I'll go ahead and write these out, is iodo, bromo, fluoro, and I ran out of room, chloro. I wrote too big. And then maybe a specific example might be like 2 bromo pentane. So something like that. All right. So then the carboxylic acid, um, it's like the R, and then since it's got an alcohol, and it also has um, the ether. I'm sorry, an alcohol and um, a ketone on it. It's got both of it. You'll just put like the C with a double bonded O here, and then an OH like that. Okay, and the way that kind of the generic name for it, it's oanoic or oic acid. So like let's go with butanoic acid. Okay, so if you had butane, there's 1, 2, 3, 4. You'd have a double bonded O here and an OH here. Ethers are written like this. Now, a lot of times you see a little like, I think it's called prime. I don't know what that's called actually, but anyway, that little symbol up there, and it just means that it can be a second kind or a different kind. It could be the same thing. It could be a methyl and a methyl, or an ethyl and ethyl. It's just saying that they're two different R's. Okay, and it's basically you just name the two ether or the two alkanes. like oops, let's go with methylpropyl ether. Methylpropyl ether would be this. And then the last one would be our ketone. And it ends with 1. So like pentanone. And then you have to say like where it is. So let's just say it's 1 pentanone. So we'll put the double bond. Oops, can't be 1 pentone. That would be an aldehyde. Let's make it 2 pentone. Right there. And then the one I don't have on here, but I want you to draw it on the chart, are the cyclos. There's really no general structure for it. And the naming of it is just the prefix cyclo. And so like if we had cyclohexane, you just draw a hexagon.